Welcome to ME 160 Engineering Drawing Part 6 Development 4.2/3. Learning Objective: demonstrate the intersection of a line and a plane by the edge view method. Introduction: a plane is a flat surface generated by moving a line in space. A plane has no boundary and extends to infinity. A plane figure is a figure of a plane limited by boundary lines. In engineering graphics, there are two types of planes: projection planes, that are HP, VP, and PP, and the general planes. Methods of determining intersection of a line and a plane. There are two methods: one, the edge view method, and two, the cutting plane method. 1. Edge view method. This method requires the edge view of the plane in determining the intersection of a line and a plane. The edge view can be provided on 1. Normal orthographic views, that is on the HP, VP, or PP, or 2. The auxiliary projection views. 1. Edge view method. A line piercing a plane can be proven when the line intersects the edge of the plane. Let's take a look at a rectangular plane figure bounded by A, B, C, D in the front view, and the top view, which is shown as an edge view. Now let us introduce a line 1, 2, and from the top view we can see the line 1, 2 and the edge view are parallel. This means the line does not intersect the edge, does not intersect the plane. Again, let us take our front view, that is the rectangular plane surface, A, B, C, D, and the top view, which is again the edge view. Now let us introduce a line 1, 2 that intersects the edge view in the top view. Now from this, we can see that the portion of 1 which is in front of the plane will be visible, and the portion of line 1, 2, that is 2, which is behind the plane, will not be visible. Now, therefore, if we want to draw our line in the front view, then the portion, first of all, let's look at the intersection point. Here, the edge view and the line intersect. So that gives us a piercing point. That's P. And now let's look at the line in the front view. Here, the line in the front view, the portion 1 is made visible, and the portion of line 1, 2 is made invisible. Now, if we are looking for the point P, the piercing point, then that is the piercing point. So the piercing point signifies a transition, the transition point between visible and non-visible. If you look at the front view, at the point P, to the left, the line is visible. To the right, the line is invisible. So it is a transition point from visibility to non-visibility. Now, edge view method. First, let's look at intersection of a line and principal planes. The point impression, that is at which a straight line, if extended, meets HP, VP, or PP, is called the trace of the line. The point impression is the piercing point at which a line, right? Now, if the plane is the principal planes, then we call that, instead of the piercing point, we will call that the trace of the line. This definition is normally restricted to only the principal planes, and therefore we have the following traces of lines are used in engineering graphics. 1. The horizontal trace, HT, of a line, and the vertical trace of a line. VT. 1.1 Edge view method. Intersection of a line and the principal planes. Horizontal trace HT of a line. If the extension of a line intersects the HB, the horizontal plane, then HT is the point of intersection. Likewise, vertical trace of a line. If the extension of a line intersects the vertical plane VP, then VT is the point of its intersection. 1.1a Edge view. We are now taking the traces of a line parallel to both HP and VP. Here we have two planes, the vertical plane and the horizontal plane. XY is our reference line. Now here we have the line AB introduced. Let's look for the front view of the line which will be projected onto the vertical plane. It gives us our horizontal line, which is front view, FV, and its point AB. Now for the top view, here that comes onto the horizontal plane. So here we have our edge, that's also a horizontal line as it should be. And we have the ends AB, and that is TV, which is the top view. Now for corresponding of projections, so that we see the relationship. Now if you take the front view and draw lines vertically downwards, right, to hit the XY plane, and then extend them to the top view, then you see the lines that we have here prove that the projection is right. Now, if we were to align the views we have on both planes such that we can see them all at the same time, that means the horizontal line is rotated downwards, so it's vertically aligned with the VP plane. Then we have the view, the figure shown on the right side, where we have the front view FV, the top view, and our line of projections or correlations shown by vertical lines showing the correspondence. Now, the XY plane, the XY reference line, depicts the edge view of the HP or VP. How? Let us look at the figure on the left side. For the figure on the left side, let us concentrate on VP. That means looking at the front view FV. Now, if we are looking at the front view, then the horizontal plane will become an edge view. So it will correspond with the line XY. So in that respect, horizontal plane is the edge view, which is XY. Likewise, if we are interested in the top view TV and we look from above, then the vertical plane will become a line, an edge view, and correspond to XY. Therefore, XY respectively represents the edge view of HP or VP accordingly. Extending the line, let's look at the figure on the right side. If we were to extend the line AB in both directions, they will never cross XY. So in that situation, there is no trace of line AB because we know XY is now an edge view of the two planes. So extending it from any respect and it doesn't intersect XY, then that means there is no any intersection between the line and the plane to any of these planes. 1b. Example, looking at the case of trace of a line inclined to HP and parallel to VP. Here we have a vertical plane, horizontal plane, reference line, which actually indicates the edge view of either VP or HP respectively. Now we have introduced our line here, AB. This line is oriented such that it makes an angle of theta to the horizontal plane. And let's look now for our projection for the front view. When we project in that way, but please note, theta, the angle theta, is the true inclination of the line to HP. If we project in that direction to the vertical plane, then we'll have the front view, which is inclined, AB, which is inclined to XY. Note XY, when we talk about the front view, then XY is the edge view of HP. Therefore, the angle of inclination is actually to the angle of inclination to HP. Therefore, the angle theta is the inclination of the line to the plane HP. Now for the top view, if we project down, we will have a line which is TV. Now let us look at the corresponding relationship of projections. As we said here, when we introduce the lines on the vertical plane and that of the horizontal plane, we have this connection. Now, if we now look at the front view, right, that is the vertical plane, and look at the front view AB and extend it in a form, it will hit XY, right? Where it hits XY, that is, as we know, XY is the edge view of HP. So which means it intersects HP, right? It intersects HP. So that point we label as H. But we have to locate the exact position. Now we have to look at the relationships of what we develop. Here we extend both directions. That is here, as we see on the horizontal plane, and the line, the true length, the TV, that's the top view as such, and that is the point where they meet. That point is the horizontal trace, HT. We can confirm that by extending the true line, and it should come to that point. So that is HT. That's the horizontal trace of the line, which is a point here. Now, so we have we have a trace of the line AB, but the trace is a horizontal trace. Now, let's look at the figure on the right side. Now, for the top view, if you extend the line AB in any direction, it never intersects XY. Therefore, it does not intersect the vertical plane. It does not intersect the vertical plane. That is the edge view of the vertical plane. So there is no trace to the vertical plane. Now let's look at the trace of a line inclined to VP and parallel to HP. So here we have our planes VP, HP. Then that is our line. Now, inclination-wise, inclined now to the vertical plane, theta, and that is a true inclination of the line to the vertical plane, theta. Now let's project for the top view. Here we have the top view, and that's TV, AB. Then that is the angle of inclination to the vertical plane. Now note that angle line is also compared to the XY, which represents the edge view of VP. Now for the top view, for the front view, if we project for the front, we obtain a horizontal line. So AB, now let's look at, that's the front view. So we now look at the correlation, and we have these two. Now, if we take now the top view on HP and extend it, you will see that it intersects XY, right? It intersects XY. Note XY here refers to the edge view of VP. So that point is V. Now we need to locate the exact point on the plane. So the correct relationship must be drawn. From V, we draw a vertical line, and then from AB, we extend that line on the front view AB, so it hits here. That is our vertical trace. But we can confirm that by drawing a line from the actual line AB, and it will intersect at that very point. And that is our VT. That is the vertical trace of the line. So here we have a vertical trace of the line. Now let us look at the views when oriented. Just like the first, that's like the second case that we had. Now if you take the front view and you extend the line AB in either directions, it will not intersect SY, which represents now the edge view of the HB. So there is no intersection of the line AB on the front view in that respect. So we have only the vertical trace of the line. Trace of a line inclined to VP and HB. Here we have our two planes, XY. Then we have our line AB, which is inclined to the two. Let's look at this. For our front view, we project, and we have FV, meaning our front image on the VP. Now let's look. Now the angle, if we look at that angle formed, that is the angle formed by FV and then XY is alpha. Now here, that is an apparent inclination of the line to HB. Apparent inclination of the line to HB. Now, AB, that is our line given. Then if we look for the front view, again, we have the top view. We have TV as the top view. Now, again, when we look at TV to respect inclination to XY, which will now be the edge view of VP, right? That is beta. So that is again the apparent inclination of the line to the vertical plane, beta, right? That is the end of the line AB. Now let's look at the correspondence. So we have the relationship showing the correspondence. Now let us take the front view from the VP. And if we have to extend that to hit the line, to intersect the line XY, which will now represent the edge view of HB, and here we have it, that is H, which means that line intersects the HB. Therefore, to properly locate it, we draw the horizontal portion of it and then the extension of the line of TV, and that will give us our HT. We can prove it by taking the true line AB and extend it in that direction to give us true HT. Likewise, if we were to look at the top view, that is TV, and we want to extend the line AB to intersect XY, this time since we are taking HB, then that means XY represents the edge view of VP. If we extend, it will intersect that line, so which means it intersects also the VP. Then that we label at V. Then to get the right point, we draw our vertical line over there and then look at the front view, FV, and extend the line over there, and that locates the vertical trace of that line. To prove we can extend the line from that place to get to that, to prove that is the actual line. So we have the trace VT and HT. Then, so let us look at the right side where we have the two planes now realigned, where we have the indication from the front view, the apparent inclination of the line to the horizontal plane being alpha, and the top view where we have the apparent inclination of the line to the vertical plane being beta. And when we look again, we can locate our VT on the vertical plane and locate our HT on the horizontal plane. Now, the true inclination of the line to HP, right? The true inclination of the line to HP will be VT, HT, and V. VT, HT, and V. That is the true angle of inclination. That's the angle formed by those points. VT, HT, note VT is on the vertical plane, HT is on the horizontal plane, and V is on the x-axis. That is the angle formed between them. Now again, the true angle of the line to the vertical plane here, that angle will be now H VT HT. That is the true angle of inclination. 1.2 Intersection of a line and general planes. The intersection of a line and a plane, that's piercing point, a general plane, can be observed when the line intersects the edge view of the plane. Requirement: it requires that we obtain a view of the line and plane in which the edge view of the plane is seen. Then it requires that the edge view and the line intersect. If yes, then there is a piercing point. If no, then there is no piercing point. The piercing point is the transition point of visibility of the line, as earlier explained. That's the piercing point. You have the visible portion of the line and the non-visible portion of the line with the plane. Edge view method, piercing point of a line in general plane. Let's look at a triangular figure bounded by A, B, C, both in the front view and the top view provided. Now let us insert a line MN in this, and now the front and top view do not contain edge view, and it is required to find the edge, to find the piercing point. We already know when you project along the true length of a line on a plane, then that will give us the edge view of that plane. So how do we get the true length of any line? Looking at these triangles, the edges from all the views, none of them is a true length. Therefore, for us to determine the direction of projection, auxiliary projection, whereby we will get the edge view of the plane, we introduce now a horizontal line in any of the view. So here, the top view, we introduce a horizontal line AD, where D is on BC. Now, for us to locate the point D on BC in the top view, we project down to locate the point D and draw the line AD. Now we know the line AD on the top view is the true length on that plane. Therefore, if we project along AD on the top view, AD on the top view, that will give us the true length. So our auxiliary projector, AP, is along the line AD on the top view. Now, for us to perform any auxiliary projection, there are principles we have to go. First, to determine the mutual view. Now, we are dealing with the top view. Therefore, the mutual view that is available currently is the front view. So we select the front view as the mutual view. Then we need to instruct our mutual projector, MP, which means projecting from the given view, that is the top view, to yield the mutual view. So that is MP. Now we intersect a reference line, XY, at a convenient point, which gives us positive and negative measurements. So here, that is inserted through the point C. So X, Y through the point C. So points in direction of VP above XY are positive, and points in the opposite direction from XY will be negative. Likewise, the reference point for the auxiliary projector, which is X1, Y1, must be determined, and it is also perpendicular to AP. So we insert that X1, Y1 perpendicular to AP at a convenient distance. Now we are ready to project. So we select our first point of projection, auxiliary projection point C, and we project here. Now we have to look at that correspondence from our mutual view. The point C is exactly on XY. Therefore, we move to our projector C, and that will be exactly on X1, Y1. Then we go for the next point, that is A, project A along the AP. Then we come to look at the distance of A from XY on the front view. We can see from A from XY, it is a positive perpendicular, is the positive perpendicular distance that we take. And we come down to X1, Y1, perpendicular to that distance is positive direction, and we get A. Then we go to B, D. Note D and A have the same distances. Therefore, A and D by the auxiliary projection will be at the same point. Then we go for B. Now, perpendicular distance from the front view from XY, we pick that and come to X1, Y1 and get that point there. If these projections are rightly done, then the edges AB, BC, and CA will all form a straight line. And that will be the edge view of our triangle. Now let us insert our line MN. Now we have to pick a convenient point on the line. So go to the front view, pick, that is the edge view. So go to the front view, pick M, small m, a point on our line MN. Now we have to locate that point on the top view. So we project downwards and locate M on that view. Then now apply the auxiliary projection AP to M on the top view, and that will be that direction. Now we look at the front view and find the distance from XY to small m. That is a positive direction. So we come over here and plot that in the auxiliary projection. Likewise, we locate a point again on the front view, N, small n, and we determine its location on the line in the top view, and that is N. Now we apply the auxiliary projection AP to it, and that is here. And we go to the front view and look at that perpendicular distance positive in X from the XY axis and bring that distance in. So we have the 2 points now. We can join these 2 points, and that is the portion of our line that we have drawn. Now we clearly see the line MN and our triangular, the edge view of our triangular plane intersect. Therefore, there is a piercing point, and that will be the piercing point. Now, we have to reference that back to the top view. We know that was at a point on the line. So therefore, from the point V, we project backward onto the line, and that will be P, the point P on the top view. Then we have to take this point from that point and project it to the top view vertically, and that will be the point P on the line over there. So we have our front view P's points showing, and we have the top view P points showing. We now have to determine the visibility of the lines. So here we have our triangular plane shown, and the lines are shown. The piercing points have already been identified. So it's left with the visibility. So we know the point P is a transition point, visibility point. So let's pick to see. Now we look at any apparent we consider any apparent point of intersection. So let's take the plan and look at the line 1, 2 and the edge AB. They appear to intersect at this point 3 on 1, 2 and A on AB. Now let us project backward to see what we get. When we project backward, first we meet the line. Therefore, we meet the point 3 on the line first before we meet A on AB. Since the point 3 is met first, that means the point 3 on the top view is not visible. So if it's not visible, the invisibility ends at P. So P, 3P will not be visible, and therefore with a dashed line. Now, left with the other portion of the line. Now let's look at the second apparent point, which can be picked from any point. Now let's look at the top view and look at our line. Now the line intersects BC, right? So we have the point B4 being an apparent intersection point. Therefore, we project downwards, and here we meet B first, right? B first on the line AB before 4. We meet B first before 4. Therefore, the front view, B is not visible because we meet B first. So if B is not visible, that means 4 is visible, right? So which means the line from that is visible to P. So the invisibility is from the point of P to the other edge. Therefore, that edge will go off and replace with a hidden line. That is the solution. Now let's look at our assignment 4. Find the piercing point of the line AB and the plane MNP by the edge view method and determine the visibility of the line. Note over here, please provide your answer legibly. Let it be clearly visible. Do not label, do not put in dimensions. Labeling of points is very important. Please note in your title block, include your name, index number, department at least, and the assignment number. That is very important. Do that and let it be clearly visible. Please, when you take a Photoshop snap, please make sure you don't use the flash, because most often the light flashes and makes the picture blurred. So please see how best you can get a good shot. I hope that is clear. Thank you. That is end of part 2, 4.2.